Okay, this is our December meeting, December 18th, 2024. First, I want to say good morning, everyone. Did everybody have some snow removal? We had our first accumulative snow, and I know we came in and moved some snow around over the other weekend. We'll see what this next storm coming up here brings. But we've got the salters ready, we got the plows ready, we're ready to go. Our last meeting was held on November 13th, 2024. Bill Lyons, Sean Hinson, and Van Wilkins with In Charge Energy, they went over their chargers, the ones that they're making still, the ones that the new ones that are going to be coming out. And they went over, he said some of the notes I had was that they provide all kinds of training, which we know. They have over 900 GM dealerships, like trucks. They are in 225 different school districts with over 1,100 electric buses on their chargers. They are a software and service-based company. So, I know that when I'm working with them, and I work with them quite often, they are pretty quick to get back on a lot of this stuff. They went over the different kinds of chargers that they use. And they do have, which I thought was really cool, is a 600 slimline charger that can charge up to 10 buses at a time. So as we move forward, that might be something that we would look into. Went over there, they said the maintenance on most of their chargers is just filters, cleaning the ports, make sure everything's not full of dirt. Twice per year, they recommend services. And their account, they do have statistic reports. So I run these reports a lot just on how many kilowatt hours that each one of our buses is consuming during a charge. And, this is going to be valuable as we move forward to, like, why is one bus consuming more than another? Is it going further? Is there something wrong with it? And this is the data that we're going to keep storing. So today's presenter is going to be Roger Harrod with Matthews Bus Sales. He's going to be presenting on disc and drum brakes, operation and maintenance. But before we do that, we want to give some people a chance that have EV buses to maybe talk about anything that they're having, any issues. Is there anybody that's in the meeting here that has EV buses that has anything to add to the EV bus part of this?
Dan, if I could offer a comment.
Yep.
One of the topics that were brought up by the people last month was the thermal load or the thermal maintenance load.
Mm-hmm.
When the weather gets cold, the batteries need to be heated to take a charge. And that's a 10 kilowatt load right off the top of whatever the charger's providing. And that was very good information. If you're charging with a 20 kilowatt charger, for example, in the wintertime, if it's not in a heated garage, you're only charging 10K. And keep in mind that that is a requirement. You want to get up, and they mentioned the sweet spot at 30K that the buses would like. That would tell me that in the winter months, I'd want a 40K charger to get the maximum charge I could on that to meet that sweet spot. That was a very interesting program last month. I learned a lot of stuff myself.
Yeah, that was really good. And for everybody at that meeting was also recorded and is posted to our channel. I can tell you that with ours, our EV2 had a vibration, and it took a while to figure it out, but it ended up being the drive shaft. So a short drive shaft between the motor and the rear end. And they put a new one in there, and it took care of our vibration. Our EV4 had an engine light on, and it was the harness, what we were thinking. And it ended up being a heating element because now we're using the heat. So it is, and you're absolutely right. That heater consumes a lot of energy. Our bus EV1 goes about 100 miles, and we now have to charge it during the day in between runs because it cut it right down to half. It was coming back right now. It just came back off its morning run. It's got 50%. So that's not going to be enough energy for the afternoon. So our thought was that we would just charge during off-peak hours, which is our chargers are supposed to come on at 7 o'clock at night, and that's when they charge because we pay less for energy. Now we're finding in the wintertime that's not going to be the case. At least 2 of our buses that have longer runs are going to have a midday charge, which the chargers are on right now, making sure that they have enough power for the afternoon. Those heaters are definitely a setback with these things. I mean, you have to have heat, and they have to produce heat, and it takes a lot of energy. But our chargers have been coming on at about 7 o'clock every night. We did have a problem last night where the guys had to go out and turn them on. So this kind of stuff, I think I said this at the last meeting, that it takes a bit of maintenance and monitoring. Like I monitor our chargers every evening to make sure that they come on. We do get emails on our phones when they don't charge or when they're connected. So there's a lot of information out there, and it's just, as we were moving forward with this, it takes a lot of monitoring. But that's what I have for the EV side of this. If nobody else has anything else to add, we'll turn the floor over to Mr. Roger Harrod. Not seeing anything. Yeah, go ahead, Roger.
Let's see if I can get this thing to present. Dan, if you would let me know if this is working. Window, I want that one. Share.
All right, it's up.
Okay, is it changing?
Yep, air
Good.
dryers, brake components.
All right, we're talking about brake components and systems. This is actually a presentation I did at the summer seminar in Syracuse. It's been updated a little bit, and again, we've had some people ask to see it again. Not so much the brakes themselves in one case, but the related items and areas that are going to get us in a little bit of trouble when we're going ahead with our bus operations. I can't start a program really without talking about air dryers. Air dryers are a major situation with any air system today, and the maintenance on these is absolutely critical. Being with the transportation industry for as many years as I have, this is one of those items that gets forgotten, and we can't forget these. You have to maintain them on a regular basis. There's a couple different types of cartridges out there. There's the traditional cartridge that most of us are using. It's designed to remove the moisture, of course, and when the unit pops, it's going to dump that moisture back outside the vehicle rather than letting it get into the air system. An advancement on that is the coalescing filter, which has an additional filter element in it, which will capture oil and other contaminants. And again, that system won't purge those components out. It will trap them. It will purge the moisture from the system. This, by the way, is a coalescing cartridge. This is actually the filter pack that's mounted in the base of it. This is what's facing the element. This is what's facing the outlet side you see over here. If you pull these off and the outlet side is brown, it's been there too long. There's a life expectancy on a coalescing cartridge is only about 6 months, but it is a better cartridge if you can use that. And again, enough said on this. ABS brakes. ABS brakes have been with us for a long time. They came out and were introduced to our marketplace in 1997 and was really an important advancement in the braking systems we're using on these vehicles. And again, I love this slide, you know, ABS off, ABS on. What does ABS do? ABS is preventing the brakes from locking up. If we lock up the brakes, we just skid. If you are applying the brakes correctly, where they aren't locking up, we have a better chance for better opportunity for a safe operation with the brake assemblies. And they are not designed to stop a vehicle quicker. They were designed to modulate the pressure to prevent that lockup, which is going to give us stability, steerability, better, more stable stopping on that slippery road surface or in a curve, and may improve stopping distances. But it's more important that we are stopping under control than absolutely a shorter in all cases. This is also going to reduce plow out and tire flat spotting. It adds some additional components, obviously, to the vehicle. I got a control unit, I got wheel sensors, got modulator valve packages, cables. And this was introduced way back in March of 1997. This system's been out a long time. The componentry there, you've got the module, you've got the modulator valves, you've got the wheel end components. ABS, by the way, is the most important processor on today's vehicles. When ABS talks, everybody listens, meaning what? It can cut engine, it can cut transmission operation, it can obviously control the brake situation. It is one of the most important components on the vehicles today. And yet the parts that really are a major problem areas are the ones that are exposed to the atmosphere. These are the ones that create about 70% of all the failures we see with ABS is in the wheel end system components. Here you see the relay valve, the rear, of course, and the two modulator valves on the rear axle. There's two additional ones on the front. But again, the ones that are creating the problem for us, 70% of failures are the wheel speed components. And it's why everything gets thrown at them. You get missing teeth, you get debris, corrosion, misalignment, loose bearings, put the wrong tire size on, messes it up. The wrong ring will create problems. The sensor, of course, the gap and shorts and loose connectors and all of those components that we've seen for so many years. Even the simple point of installing the sensor correctly. And again, that sensor should actually be lubricated because it has to have the ability to move in and out. Installing it, you just push it in and touch the tone ring with it. Well, the vehicle is not moving, obviously. The wheel run out, the first time it goes around, will knock that probe back at the proper location and will set the gap. And this should be checked with every brake job. Now, if the run out on the axle is correct, this wheel gap will be set automatically on the initial rotation. You really don't even have to go in and measure it. It should work fine. Now, there's all kinds of sensor diagnostics. I am not going to go through all these points individually. Dan already has a handout of this entire presentation. If you need these numbers and such, they'll be on the handout. But again, one of the important ones, of course, is just spinning the wheel in the air and to check to see if there's an AC output on that sensor. Now, to make this check, you're going to need some type of adapter. And again, this is a very common situation. You just buy an extra whip, put some alligator clips on it, and you've got a tool you can use for resistance and shorts and the AC voltage on the system. A more important point, however, is replacing components on these. Wabco, for instance, at one time had over 400 part numbers of different modules pre-programmed to provide you a replacement component for your applications. They stopped stocking all those units a good number of years ago and went to around a dozen units, but that required that every new unit had to be programmed before you could put it in your application. The information for this programming, by the way, is on the old unit. All the numbers there you need. There's actually a form you would fill in with this information. You could then reprogram the unit. Now, you can buy the software for this. The Wabco software is available. You can actually program these ECUs yourself. They can be done in the chassis or they can be on the bench with the appropriate adapters. But this is something which you have to keep in mind. You can't just buy a new ABS ECU today and just put it in your vehicle and expect it to work. It has to be pre-programmed. And this is something you can do yourself, or more correctly, in a lot of cases, whoever's supplying it to you should have the ability to pre-program this before they send it to you, and then you can just install it and use it in your application. Now, the next big change in the system was the advancement of ATC, automatic traction control, and that occurred in 2012. The changes there, they added another valve, an automatic traction valve that was located at the rear axle, and this job is to prevent the loss of traction. Now, this system allows the system to sense with the ATC, sense a wheel spinning, and would allow the system to apply the brakes on that wheel, transferring the torque to the wheel that's not spinning, and again, giving you better traction. It was a very practical system. It works very, very well. And that really isn't a lot more to be said about that system. The next change, however, was a big one. That was the electronic stability control. That control change came in 2018. This was a major improvement in the system. Gave us some more lights on the dash to look at, and gave us some more components. We had another ETC valve, which is not actually an ATC valve, added a steering sensor, a yaw sensor, and a brake sensor. Now, what does this system try to do? This system tries to prevent this from occurring right here. We don't want the vehicle rolling over. We don't want to lose control. This monitors the vehicle's rollover threshold. It it'll activate to slow the vehicle if a threshold is exceeded. It does all this wonderful stuff to keep our vehicles a lot safer. And it did it with the addition of some additional componentry. One of them is the steering angle sensor. Okay, this must be calibrated when it's installed in a vehicle. You have to tell it where straight is. And it's located under the steering wheel. Now, another component is the ESC module. This is mounted on the rear axle, near the rear axle. It contains a lateral accelerometer and a yaw rate sensor. And this must be initialized when it's installed on a vehicle. And this is all done with Wabco's Toolbox software. Now, again, located in the rear, and it cannot be relocated. It's set in one position. It has to be there to monitor these areas correctly. Now, the last sensor they added was a brake pressure sensor, and the Thomas product is my right under the hood up here. This senses the actual pressure the driver is applying to the system. It's not an on-off switch. It's a proportional switch. And again, ours is typically located under the hood. The additional active braking valve is located between the front and rear axles and allows us to control that pressure to the front axle as well, the duplicate of the ATC valve. And again, it's directing the air pressure to the steering valves, to the steering axle valves. Again, ours is located just about the same area as the battery box inside the frame rails. Now, ETC is an interesting topic to try to discuss what it actually is doing. It's all about pivot. And what I'm talking about here is the steering angle sensor. It knows where the driver is pointing the front of the vehicle. It knows the position of the front tires. The ETC module has the ability to understand where the vehicle is actually going. Again, the SAS is identifying where the driver wants to go. And the ETC module says where it's actually going.
Hey,
Now,
you'll see if this comes back. We're locking up here, I think.
And start. You might not safely make it through the turn. Electronic stability control is a feature that can help you avoid this kind of disaster. About half of all fatal passenger vehicle crashes on U.S. roads involve a single vehicle, and crash studies indicate that EST and half. EST sensors continuously monitor the driver's steering input and can tell if the vehicle is pointed in the intended direction. On slippery roads, curves, or in emergency maneuvers, the front end of a vehicle may start to plow ahead, or the rear end may spin out. When this occurs, ESC brakes individual wheels to maintain control. They may also reduce engine speed to bring the car back into the intended line of travel. That ESC from clear. Every vehicle on the road has ESC. We might avoid as many as 600,000 single vehicle crashes each year. And
Well, but again, let's take a look at this. What's an understeer, for example? The driver wants to go here, but the vehicle goes there instead. We are understeering. The vehicle, motion of the vehicle is not allowing it to turn. The pivot is not pivoting correctly. So what electronic stability control will do, again, it knows where the driver wants to go. The ESC module knows where it's going. In this case, we have an understeer. What the system would do is would apply the brake on the inside rear, which is going to try to pivot the vehicle around into the intended path. It can also reduce the throttle as necessary to maintain that. Oversteer, again, the driver's intent is to go to this position. What's happening is not. It's going straight ahead. The vehicle's just going through it. So again, what electronic stability control would attempt to do here, again, it knows where the driver wants to go. That tells me where it's going. So what it would actually do in this case, it would apply the outside front brake to, again, pivot the vehicle down into the intended path, also reducing the throttle as necessary to reduce that. Now, all this wonderful electronic stuff can create some problems for us. And as a dealer trying to maintain equipment for our customers, we get these calls all the time. This bus is making this noise, or we have a hammering sound, or we have something that's going on crazy. Let me give you something to consider here. This is an example of the vehicle trying to make a right turn. And so I use my graphics to actually plot out how the vehicle would have to go around that corner to make a right turn. And it took 6 frames for that vehicle to make that turn. Now I did the same thing for a vehicle turning left. The same plotting, just to plot out where I'd have to make that turn to get that vehicle's wheels headed in the right direction. And it took only 5 frames to do that. What does this represent? Well, the truth is, it's easier to make a left turn than it is to make a right turn. It also can be turned at a higher road speed, left turns than right turns, because there's more room for the turn. Evaluating a braking condition, keep in mind the difference in the speed of the vehicle. For example, these new electronic systems work in milliseconds. They can really react to a situation. But in particular, drum brakes have a lot of components in them that have to operate together for them to make a reaction to something, to a command. We are seeing a lot of situations where we have these hammering noises or abrupt braking responses or changes in operation, more often than not in a left-hand turn and more often than not with drum brakes. We send our technicians out to evaluate these situations, and quite often we have a hard time duplicating what happens with their own drivers unless we push the vehicle to the limits. And when we get there, all of a sudden they say, oh yes, there's that noise again. And what we had to do that is really push the vehicle as hard as we could. The truth of the matter is today's vehicles, these electronic systems can respond faster than the mechanicals can. And at times when we have a situation like this with a brake noise or a hammering or whatever it is, look at the situation. Is it a left turn? Is it a right turn? How fast? Is the driver causing the problem by actually just pushing the vehicle to its limits? Because there is a limit as to what these systems can do. Keep this in mind. This is a valuable tool. All right. To diagnose any of these systems with Meritor Wabco prop, we need the toolware software or toolbox software, and you have to have at least version 12 or higher. This is an example of that software, and there's the option we would use to make most of these changes, and in particular the ESC system. There's actually a menu up here for ESC, and if you click on it, you end up with only one option. It's called end of line. It's called that because that's where this option is used. As Thomas or IC or Bluebird build a bus and it comes off the end of the production line, the very next thing that has to be done is they drive the vehicle out into the parking lot and at the end of line, and they set up the parameters for the ESC system. This is set up individually for every bus. Every bus is unique. There is no pre-programmed software they put in these. They actually do this for every vehicle. Now, when you click on it, you have to set up both the steering angle sensor and you have to initialize the ESC module. The steering angle sensor is actually quite simple to set up. You're basically telling it, it has to learn when the steering wheel is aimed straight ahead. Okay? This has to be done, by the way, anytime any alignment has changed on this assembly. For example, you had a front end alignment. You've changed the position of that sensor slightly. This has to be redone with that. Or if you've replaced any components in the system, it needs to be redone. But it's actually quite simple. You just hit SAS calibration. It'll give you a first screen. I'm not going to go through everything on these screens, but basically you have to align the front wheel so it's going straight. You push the space bar on your computer. When the light comes on and goes to blinking and closes, it's done. It's a very quick process. Now, we have to set the ESC module. ESC module has to know how the vehicle reacts when it's being driven. And there's two tests that have to be performed here. And we have to make sure the ESC is done first. We have to do a straight driving test, and then we have to do a steering ratio calculation. Now, the straight driving test, very simple. You drive the vehicle straight ahead, and you have to accumulate 500 foot of travel straight ahead at 15 miles per hour. And when that's done, the ATC lamp will stop blinking. It will remain on. That test has been completed. You then have to do the steering ratio calculation. The vehicle has to come to a complete stop. You then rotate the steering wheel, either clockwise or counterclockwise, doesn't matter, because we're going to do the other one also. 360 degrees, and accelerate slowly until you reach 12 miles an hour. That system is going to tell you then you're there. You have to continue doing that until the lamp turns off. You then stop the vehicle, you turn the steering wheel the other direction 360 degrees, and you repeat the same process again. When you've accomplished that, you then power down the module, restart it, check for faults. If everything's good, you're done. It's a very simple process. The problem is you have to have the software to do these repairs. If someone else is doing this for you, you have to make sure they have the software to complete the repairs properly. Now, this software, this is the older version of software, was around $400 a year. There's a new version that's just come out called Toolbox Plus. Looks a little bit easier to use. I have not used this newer software yet. Cost is about the same, about $400 a year. If you're doing a lot of repairs in this situation, I recommend you buy the tool. If you do this occasionally, it might be better to make certain that the facilities doing your work have the ability to program it. Make sure they've got the software so that they can put your units back into service correctly. Now, we're going to go on to some other areas other than electronics. Air disc brakes are the big thing today. Bendix is the main supplier in the school bus industry. They produce a good product. In the European market, this is all that they use. Now, here we have the Bendix model ADB, which stands for Air Disc Brakes, 22X. That's the brake version that we're using in the school bus industry across the board, both in the front and rear. Now, this particular one is a 22X. Thomas uses a -V version. It's slightly different. Has to do with these bolts right back here, and I will show you the difference in this a little bit later. Daimler, in fact, uses the V only. Now, C2, we also have a requirement on front hubs. We have to go to aluminum hubs. That's for heat dissipation and weight specific. And on our Class Ds, our HDX, because of the clearance situation on the back of the brake, we have to make certain the suspension is properly ordered. Again, internal automatic brake adjustments. This brake is always ready to use. It's a very, very, very good brake package. Stage stable, and again, minimize brake variation between individuals. Why the move to disc brakes? Well, they've got a better stopping distance than conventional drums, even the high-performance drums. They're fade resistant. They use an awful lot less air. Now, keep in mind, with your electric vehicles, air compressors are driven electrically. This is a reduction in battery consumption by itself. With the electric vehicles out there today, I would certainly want to look at air disc brakes in all cases. And there's a lot less moving parts, and they're much, much easier to service. Now, an operation, this is a comparison of FMVSS stopping distance requirement is 60. With air drums, about 238 is about it. Disc brakes are 18% better. They're under 100 feet. It's a nice package. And probably the most valuable part today is the number of moving parts in a disc brake system is so far less than there is in a conventional drum brake arrangement. You've got your supply port working against the diaphragm. It has a single push rod that comes in and pushes against the lever. See the lever here in black. The lever has what's called an eccentric bearing on it. How this works is very simple. The cam action of this, as the push rod pushes it in, that eccentric bearing will push the bridge in. The bridge goes across two tappets, which just close the distance between the pads and the rotor, stopping the vehicle. Very, very few moving parts. Nothing external on this. Everything is inside the caliper assembly itself. In fact, these components in here aren't even serviceable. They don't need to be. Now, the rotors and pads on air disc brakes are the same on the front and the rear axle. There is no difference in part numbers between the rotors and discs. The calipers are directional sensitive, meaning what? You've got a left-hand caliper used on the front and rear axle. You've got a right-hand caliper used on the front and rear axle. There's only two calipers. One's for the right side, one's for the left side, whether they're in front or rear axles. And there's an awful lot less parts involved in these. Now, externally on the assembly, there are some casting marks that I do have to point out. You got one on the caliper, one on the caliper assembly on the carrier. And when you put in new pads, these two marks will show you you've got a lot of pad here. And this was designed for the trucking business because they wanted to know sometime, when do we have to inspect this assembly? When the notches lined up, that was an indication for an inspection. Now, it doesn't mean they're out of service. It just means they should be inspected at this point. This is something that in the school bus industry is pretty impractical because DOT will not allow us to do this. They want to physically see the pads, which you can see right here. This is a working system. This one has 13,000 miles on it. This has got exceptional wear on this one with no engine brakes. But you can even see the tappet boots here. The tappet boots are the seals around the tappets themselves, allowing the tappets to move in and out and compress the pads, but protecting the seal area, that area inside there, for any contaminants or dirt. And this is an area we do have to check on a regular basis. We'll see more of this in just a minute. And we do have what we call a conventional or U-shaped rotor being used in this particular example. To inspect the clearance on the pads themselves, it's very simple. You just move the caliper inboard, take two feeler gauges, and it's going to take, they're going to be checking for a 24 to 43 thousandths clearance. If we've got that proper clearance in there, that is adjusted correctly. There's no problems with it. Now, to replace the pads, they're really very, very simple. No need to remove the caliper or rotors. You can do it on the you can do it on the axle. You don't have to pull anything off. But it's recommended that you change axle sets. You never want to change just the right side pad. You want to change both pads on an axle so you'll get equal braking on the assembly. To replace the pads, first thing we have to do is to cage or release the cage as necessary, proper jack stands and all the rest of that information. But the first thing we do is right here, we remove this cap. And that's cap 37. That's a rubber cap, which covers the adapter, which is actually called the shear adapter, which aligns on the adjuster. And the adjuster is how we adjust the internal components of the caliper assembly. Now, we're then going to put a box end wrench or socket on the end of that adapter right there. And we're going to turn that counterclockwise to back the tappets off back into the body of the assembly. If you do this correctly, you will hear clicking, and that's the slack adjuster inside the assembly actually clicking off, a normal reaction. Now, don't use an open end wrench on that adapter. There's the adapter right there. You can see the hex on this side of it. The inside of that edge is a threaded or a chambered area. That's designed to spline on to the adjuster, part 23 here, and make the adjustments. Now, the problem is if you get the wrong technician on here with the wrong ideas in life, he can actually turn that so far that he could actually destroy the internal components inside the caliper. This is designed to fail before that happens. That's why it's called the shear adapter. It will shear off. And that prevents the technician from causing any internal damage in the assembly. I have had the biggest problem with the air disc brakes is encouraging the operator to continue turning on this component and not worry about breaking the shear adapter, because you get two new ones with the pad kit anyways. So if you broke them, so what? You just pull the pieces out. You have to have had all the tappet pulled all the way in at that point, so you should be in good shape. This, by the way, is an example of a type -V assembly. This has the vertical bolts, The slide we saw earlier had horizontal bolts, which put the anchor plate and the caliper assembly, bolt them together. And this is actually a dash V. Now, to replace the pads, after you remove the clip, the washer, the pin, and the pad retainer, unless you're just inspecting the assembly, you throw them away. Now, again, I've seen technicians use all type of materials on here, painting these and putting never sees on them and all that stuff so that they aren't going to rust up. And it really is kind of useless information because you're just going to throw them away the next time you change the pads. So you can just put them in and disregard them at the end. Now, to remove the outer pad, slide the caliper one way. To remove the inner pad, slide the caliper the other way, and they'll just pop out. And the biggest reason why they don't just come out is someone has not backed off on the slack adjuster enough. You've got to put your socket down there and turn the shear adapter so we get the tappets all the way back inside the caliper assembly. Why you have the pads out is that's an optimum time to check the rotor. Now the rotor, here's all the thicknesses on it. The thickness of a new pad, well, it's 30 millimeters. The backing plate, B, is 9 millimeters. The minimum thickness on the pad is just 2 millimeters. Now that 2 millimeters is about the thickness of a nickel. If you put a nickel up next to it and that's still got more than that, it's actually within spec. And the minimum thickness on a worn pad assembly, D, that's 11 millimeters. Now, the rotor itself can be turned. The thickness on a new rotor is 177 or 45 millimeters. That's the dimension E. But the minimum is 37. This is 39. That only leaves you 2 millimeters left. Typically, a rotor is good for 3 sets of pads. You can try to save this and reuse them, but again, you don't have a lot of room left when you're through with this. Now, I do want to point something out here. There's the picture we saw earlier of the rotor. And please note that that inner surface is thinner than the outer section. Now, this picture is actually incorrect because how the rotor should look on this diagram is like this. The inner surface is purposely thinner. Why? It's to balance the heat load between this side of the rotor and this side of the rotor that has all this additional material in it. This is so that when the rotor gets hot, it deforms uniformly and just increases inside and doesn't cup. We have to have this difference here to allow this to thermally expand correctly. That is absolutely a new package. Now, other areas of the rotor, if we got surface cracks, really not a problem. There's no need for action on that. Even some radial cracks, as long as they don't get to the outer edges and they're less than 0.006 or 0.06 of an inch, we're totally acceptable. As are circumferential grooves, as long as they've been at least less than 1.5 millimeter deep, they're totally acceptable. There's no problem with that. But radial cracks that go out and hit the outer edge are not acceptable. That rotor would have to be changed. Now, here we've got that conventional U-shaped rotor, and we've got the assembly which mounts over it. On the assembly, there are 4 shafts. There are 2 tappets, which extend out and actually compress the pads against the rotor. And we have 2 guide pins. These are all exposed on the inner edge of this assembly, and therefore there are seals on them, or boot seals on the tappets and the guide pins. These have to be inspected on a regular basis. Those are the ones we looked at earlier right here. If they are damaged, cut, leaking, whatever, they can be replaced. Now, to replace the pads, you got to make sure that the springs are attached. I've seen these pads, come out of the box and the springs are loose. They're just laying in the box there. just put them back on the assembly. Once the strap goes across this, they're not going to go anywhere, but make sure the springs are on the assembly. Okay. To install them, make sure the pad wear surface faces the rotor. That's always a good way to do it. But again, moving it back and forth, we can install both those pads. We would then turn the shear adapter, the new shear adapter, clockwise. This is going to move the tappets in against the assembly, against the rotor, and we're going to tighten them in until we're tight against the pad. How's tight? How much is tight? Well, tight is you could rotate the wheel, and then all of a sudden you tighten it a little bit more, and now the wheel doesn't want to move. Tappets are now all the way in. Now you have to set an initial adjustment on these. You do that by turning it counterclockwise until you hear 3 clicks. This is actually looser than it has to be, but what it does, it sets up the internal components to the point where they can now finalize that adjustment correctly. And that's what you want to look. You want to look here, 3 clicks, and go from there. Now, all of this information is in the service data sheet provided by Bendix. Everything we've talked about except one. The rotors and hubs are Freightliner pieces. That information is in the Freightliner manuals. If you don't have this and you are working on your brakes, call one of us, call either Thomas, IC, or Bird, and say, I need a copy of the Bendix service data sheet, and we'll get you a sheet. That's cheap. Same with parts. All the parts for the brakes themselves, all of these pieces are in the Bendix parts manual. The rotor and hubs, in the case of Freightliner, are in the Freightliner system. Now, here we can talk about one other area. Thomas uses the dash V, or vertical bolt arrangement. What is that? That's between the anchor plate and the carrier assembly here. We have 3 bolts that are vertically applied versus horizontally applied, which is the 22X version alone. Now, the difference between this, most OEMs are using the ABD 22X model. Daimler uses the dash V because it affords them a different offset, and that's what Daimler wants. And the only difference is the anchor plate to caliper. There's no other changes in the assembly. In fact, here's the non-Daimler package or non-Freightliner. You see the anchor plate, you see the caliper actuator assembly. There are 3 bolts and 3 bolts, and they pass through the anchor plate into these holes right here on the caliper assembly. Now on the Daimler package, we have a different anchor plate, a different vertical carrier assembly, and the bolts go vertically up through into the caliper. Same with the rear. Horizontal, vertical. And this affords Thomas at the offset they would prefer to use with the rotors we're using. There's one other option shown on this slide. It's the optional dust shield. We do not have a dust shield on the Thomas product. I have seen this installed on the Bird and IC packages. I went to the point of asking Bendix, I said, why do they have it and we don't have it? And are we missing something? Or what's the reason? And their answer was very coy. They said, well, you really don't need it, but it's nice to have. And what they meant by that is on a 2-axle vehicle, you don't have enough really dust and debris being kicked up where you need that optional shield. In fact, the discs will tend to clean themselves out pretty good. I said, well, if that's the case, then why do you sell that? And they said, we sell it to you for trailers, because a trailer has multiple axles in front of it, gets a lot of dust thrown up, and in a trailer situation, the dust shield is somewhat of a benefit. So there's your option. You can have it or not. Depends on what you want. The only other area that changes on the Thomas product is our hubs. I'm not certain what is done on the other manufacturers, but I know that in Thomas we use the aluminum front hubs, and that's a heat dissipation thing. It helps to remove some of the heat from the system. All right, this is a parts list. The yellow items are the ones used by Thomas. We have a pad kit. The pads includes all the pads we need for an axle, including all the other little pieces, including the shear adapters. We then have a tappet boot kit. Those are those rubber seals we see over the tappets and the guide pins. You can buy the replacements of those. In fact, if there has been internal damage on those guide pins and such, we have guide pin kits. One of those kits has no bushings in it in case we don't have that damage necessary. We then have the actuators for front and rear axle. We have the calipers, and of course, these are the offset calipers that we're using, the vertical ones, and these are the horizontal ones up here. And then rotors and hubs, we do not use the Bendix components. We use some other brands, which are totally acceptable by Bendix. There is an optional pad kit, and it's right here. We have had some districts that said we really would like to get a little bit more time on our pads, and these are wearing down. Have a heavy duty pad kit, which is an option. If you tell our parts people you want the heavy duty kit, you don't need to give them a part number because it's right in our part system. They will just send you the heavy duty kits instead of the normal ones. There are some special tools available on the system if you wish to do your own work on these. These are used for the tappet and boot assemblies. This is the inner seal installing tool. We have a wedge fork removal of the tappet and boot, and we have a ring, which is a spacer used with these pieces to install the tappet boot assemblies. This is a very, very simple package. And the important part of this slide, the most important part is this address right here below it. Bendix has a wonderful library available, which you can go to and get all kinds of information on these systems. It's well done. It's at no charge. So keep that one in mind. We do have to talk about one more option here, and that is a feature which we're now using on our electric vehicles. It's now an option on our diesels. It's standard on the electrics, called the IntelliPark park brake system. This system is an electric switch versus the old PP1 valve, but you still pull to apply, you still push to release. The difference is it takes one finger to do this. To operate, the ignition must be on. It's 12 volt. To release it, in the case of the Thomas product, you must put your foot on the service brake. We have park brake interlock as standard on all vehicles we sell. The LED will be on when it's applied. It will be off when it's released. And there's two LEDs. Now, we'll go through the operation of those two things separately. System may be manually applied for emergency braking. You can go down the road and pull back on this and it'll apply the brakes. And we'll talk about that in a little bit more detail in a minute here. This is the part that gets kind of fun. If a Thomas bus sits idle for 30 seconds at very low speed or stopped with no throttle or service brakes not applied, IntelliPark will apply all by itself.
IntelliPark is designed to help drivers mitigate rollaway and runaway crashes. How? By setting the parking brake if the driver forgets to, or if it is accidentally disengaged.
Now, the important part of this statement is Thomas bus. This was our choice of how we're going to operate it in our system. This system has all kinds of ways it will apply the parking brake automatically. It is up to the manufacturer to tell Bendix which way they want it. For example, I believe in the ICs, the interlock is the driver's seatbelt and the entry door being open. Getting around this, what I'm trying to tell you is this system will operate differently depending on the manufacturer. In fact, Freightliner and their trucks does not use these particular areas. They use the driver's door and some other timer functions. But on a Thomas bus, it's 30 seconds. Low speed or stop, no throttle, no service brakes. This system will apply itself all by itself. When auto applied, you may have seen it in the video, the lights just don't go on. They both flash. And that's telling the driver, you didn't set the park brake, I did. In that case, you can't just turn it off. What they have to do is the driver has to go over and just pull back on the switch to set it manually. It will then be able to be pushed and turned off. You have to go the additional step. Now, again, to get it, you set it, you just pull and release the switch, brakes are set on. To release it, with our system, you have to depress the service brake and then press and release the switch, brakes are off. And an anti-rollaway, you're going to have to set the brake so you can turn the brake off. Special operation, above 12 miles an hour. If you pull back on this switch and hold it, it will apply the brakes with a spring modulation, which will give you somewhat of a controlled deceleration without using the service brakes. Below 12 miles per hour, however, it will set the brakes. Of course, this is DOT requirement. DOT requires that we have an ability to lock up the brakes at low speed. Below 12 miles an hour, it will set the brakes and will just lock up the rear axle. Okay, other areas on this. The following procedure is used to perform tests on the system. Okay, these are the driver's pre and post run tests. What they're supposed to be doing every day. And the important part of that is we've got an electric system doing it versus the mechanical PP1 valve. Both lights will illuminate when the park brake is set. Both lights will go off when when parking brake is released. Keep that in mind. Now the test itself, the first tests are done with park brake off. There is no difference in these tests with the IntelliPark system than there is with the conventional system. There's no difference in them. You're doing the same things. Park brake off. Then we complete the remainder of them with the park brake on. There's your air pressure recovery, your governor cutout, your governor cut in, your spring brake test, and of course your service brake test, all done with the park brake on. Now, again, there's no difference here between what we're doing already or with this system. It's just a different park brake switch. Now, this is an important slide. One thing we have lost recently is the wigwag. And a lot of us didn't care much about the wigwags, but the important part of the wigwag, it was a visual clue to the driver. If the wigwag wouldn't stay up, we don't have sufficient air pressure to move the vehicle correctly. IntelliPark actually gives it back to us. How so? Follow this layout. If the upper lamp is on, I'm not talking about the lower lamp. If the upper lamp is on with IntelliPark, the park brake is set. If the upper lamp is off, the park brake is not set. Now, under normal situations, the upper lamp and the lower lamp will do the same thing. When the park brake's on, both of these will be illuminated. When the park brake is off, both will be not illuminated. However, if the lower lamp is blinking, I don't care what the upper lamp's doing. If the lower lamp is blinking, air pressure is low. That's your wigwag. In fact, there's two cases here. If the park brake is set, that low pressure sense is at 60 psi. If the park brake is released, it's 90 psi. If the upper lamp is not blinking, the lower lamp is telling the driver, we don't have sufficient air pressure. That's your wigwag. Now, there's only one case where it will change, and that's if you see a light on the dash, say a brake light, or on one of our dashes, actually says the IntelliPark is having a problem. You have a fault code. There's something wrong with the system that should be maintained, should be looked at. Now, if both lamps are blinking, that's that anti-rollaway thing. The driver has not set the parking brakes, the system did. Both lamps blinking. And again, we've got an exception here. If you've got an additional brake light on the dash someplace, we've got a fault code involved in that too. Brake status is your top light. If the brake status is on, you've got your park brake on. If the brake status is off, park brake is off. If this guy's blinking, it's also telling you you've got low air pressure in the system. Low pressure. DOT air brake test. Every 6 months, we're going to have to do a DOT brake test. And with the Thomas bus, we're going to start the engine, bring both tanks to 100 PSI. Nothing's changed. We're then going to, on drum brakes, measure your brake throw. The problem is the IntelliPark system is designed, if you don't do anything for 30 seconds, to apply the park brake. And I don't really think the DOT inspector is going to appreciate the park brake going on halfway through him messing around with that brake throw. So what we have found we can do with the system to keep it from doing that is to, while a test is being performed, have the operator, the engine isn't running, have the operator in the cab push on the throttle pedal continuously during the test. This disrupts that 30-second cycle used to activate the park brake, and it will never apply. Okay? Now, next step is, of course, to drop your wet tank. Both gauges should hold. Drop your auxiliary tank. Secondary gauge should go to 50. No difference in your current arrangement here. You haven't changed anything as far as the test. The only thing we've done is the operator up inside the cab has got his foot on the throttle. Now, again, start the engine, bring both tanks to 100, and then complete the test as normal. Thomas bus uses the throttle as a way of disarming the system. With the IC and Bird units, you're going to have to talk to those dealers and find out what has to be done on those units to disrupt this system, because it will apply to park brakes during the DOT brake test. Any questions?
Hey, Roger, I had a question on your adjustment. You said 3 clicks, so you tighten it all the way up, and then you back it off 3 clicks. Correct?
That's correct.
Okay, is that the same for the front and the back?
Yep.
Okay,
Exactly the same. Exactly the same.
So if you had none of us do, but if you had a trailer, tri-axle trailer, it would be the same on all of those?
Can't tell you that. We
Right,
don't
but
sell trailers.
as far as we are concerned here, it's all front back brakes, tighten it all the way up, and back it off 3 clicks.
Yep.
Okay.
Now, some of the early manuals had 2 clicks, and they actually changed it to 1 click, and then they came back and said, no, 3 clicks is a safer way. That allows the system to set itself up so it likes it.
Mm-hmm.
And it'll work well.
Okay. Does anybody else have any questions for Roger? All right, not seeing any. Roger, if we do get some questions, I will definitely forward them to you as we go forward. I want to thank you for the presentation. It was a lot of information. And like I said, we're all going to be involved with this. I know our new buses have them. So we'll be right involved with this, changing those brake pads, checking the measuring. So this was a lot of good information here today.
The mechanical side is the easy part, Dan. The hard part is understanding what the electronics is trying to do. And it is, the electronics are marvelous. They've got some they've done some things well on all these packages. It's just hard to comprehend at times just how fast they work. And have a Merry Christmas.
Yeah, absolutely. You as well. All right. Well, our next meeting will be held on January 15th. We've got, as of now, it's going to be on tires. Mike White with Warren Tires is going to be our presenter, and they're going to go over the difference between the EV tires and the tires that we've normally been running, and different issues that they're having with between the EVs and the regular bus tires. So that'll be January 15th. Our summer seminar, we're getting an early jump on it this time. It is going to happen. It is scheduled for, the show will be July 17th, 2025. Setup will be on July 16th, 2025. That's all the information that we have at this point. We're still waiting on the New York State, Pete Marini with New York State to state chapter to give me any more information on this. Does anybody else have anything to add to today's meeting?
Yeah, I have a question for Roger. You talked about with the IntelliPark for DOT when it automatically comes on. Did you talk about brake service where the IntelliPark locks their brake up? When you want to pull the rear drums off, we pretty much do the same thing. I know there is a program, and we had an issue with the dealer and the factory on the key on, key off to disassemble that whole thing. And that doesn't always work every time. So we do the same thing during brake service. We leave the key on, wedge something against the gas pedal, and then do your rear brake service. So the rear brake doesn't come on.
Well, there is a procedure. It's kind of messy. It takes about a minute to move all the switches and make the changes. They obviously, it's complicated because they don't want it inadvertently disabled by an operator.
Correct.
So it's a little bit complex. It's a full slide, but it takes probably a minute to go through all the switch changes. You got to cycle the ignition switch about 20 times, and
right. We do that a few times, and that's why we just do the same thing with during DOT. We just wedge something and leave the key on, service the rear, and then button it up, and then we're done.
It's an absolutely necessary procedure because we don't want the driver to inadvertently turn it off.
Right.
That it has to be safeguarded in such sense. The software from Bendix can disable it there. So if you have the Bendix software, you can go in and turn it off for brake service there as well.
All right, Justin, you had a question? Justin Kerr? Maybe texted it. Nope, I don't see any other questions. Okay, with that being said, we will look forward to our next meeting. And anybody that has any questions for Roger, please send them our way, and we'll make sure that they are answered. As of now, I'm going to close the meeting. Everybody have a great Christmas.